Hey everybody, Miss Dr. B here, doing the last video of the stoichiometry series. We're going to be dealing today with mass to molecule problems. Sometimes you're going to see it say mass to atoms or mass to particles. It's really just mass to the number of items of anything, and generally we're dealing with chemical species. So anyway, this is the final type of your basic stoichiometry type problem. So far we have been dealing with mass and moles, and that's really about it. And so because of it, you've used two of the three definitions or conversion factors. We've used molar ratio and we've used molar mass of both the known and the unknown. We're going to still continue using those, but we're also going to add the third and final definition, conversion factor, which is known as Avogadro's constant. All right, so let me show you the two resources. And by looking at the two resources, maybe it'll help you understand what we've done and what we're going to do, okay? So in the blue circles, whether you've used a stoichiometry roadmap or the other graphic organizer, you will see what we have done. We've gone anywhere from mass to mass, mass to moles, moles to moles, and so on either one of these. And you'll see for stoichiometry roadmap, it's really pretty much through the middle, and for the other graphic organizer, it's pretty much on the bottom section of it. In both cases, we have to use the red box, which is your molar ratio. You can't do one of these problems without molar ratios, so please remember that one's going to be used even as we move into today's material. Okay, so let me take those off of there. So we have two different types of problems we're going to be working. The first one is the yellow version, and that's where we're going to start with the number of particles. Again, it might be molecules, it might be atoms, I don't know, but it's just going to be number of items. We are going to use Avogadro's number using the green box there to get down to moles of the known, and then we'll move across to go to mass of the unknown using the second green box, which is molar mass. All right? If you look at the other version of it, you're going to see the same process, where you're going to be using molar Avogadro's number, and then you're going to be using molar mass to be able to get down to the mass of the unknown. All right? The other version of this is to be able to go through with using the purple boxes, which is mass to particles. And you'll see on the stoichiometry roadmap that you'll see that we have the molar mass first, then the molar ratio, and then we're using Avogadro's number the opposite direction. Same thing goes with the other graphic organizer. We're going to go with molar mass. You'll see and then you're going to go up to through moles, and up to molar number of molecules. Sorry. So it's the same thing. It's 1, 2, or 3 sets of problems. In this particular case, it's going to be 3 different. You're going to use all 3 problems. You're going to be using molar, or all 3 definitions, sorry. Molar mass, molar ratio, and Avogadro's number. Sometimes you start with Avogadro's and end with molar mass. Other times you start with molar mass and end with Avogadro's. No matter what you do, molar ratio is in the middle. So let me just show you this. All right. So this is a mass to particles problem. I'm going to work 2 problems when we get finished with these, and we're going to kind of go back to this. So I'm going to do this one, and I'm going to show you the problem, and then what we're going to do is we're going to go to the second one. So your setup should look like this for mass to particles. Question mark, how many particles? And you are going to start with grams. So in this particular case, you're going to be starting in the bottom section. Right, you're starting on the left at the bottom, and you're going to the right at the top. And so you're going to do exactly what we've done before. We're going to choose the correct definition so that the bottom unit matches the top of the math problem in front of it. So you have moles of K over grams of K, which is molar mass. All right, we're at moles of K. We now need to go over to moles of U. Well, what are we going to do? In order to do that, you follow the arrow, and it says we're going to use molar ratio. And so that's what you're going to use is moles of the unknown over moles of the known. Moles of known goes on the bottom so that you can cancel it. And then the final step, we're now to moles of unknown. We need to get up to number of particles of the unknown. So what do? But we follow the arrow upward. We use Avogadro's number, which is 6.02. We're going to just go with 6.02 rather than 6.023 times 10 to the 23 particles of the unknown is equal to 1 mole of the unknown. All right, so let me do this, and here's the problem, the first problem we're going to work. All right, so in this particular case, guys, we have silver nitrate and copper and silver and copper nitrate, and the question says how many copper atoms. So we're going to start out with copper atoms are needed to react with 821.3 grams of silver nitrate. Right? Well, if you go back over to this, we're starting here, and we have to get up here. So what are we going to do? We're going to use molar mass of silver, where silver is, but we need grams on the bottom. Why do we need grams on the bottom? So we can cancel it out, and that's per mole of silver nitrate. So our grams cancel. All right, our second step is going to go from moles of K to moles of U. That's molar ratio. We see that we are looking with nitrate and copper, with nitrate being our known. That goes on the bottom. And copper goes on the top, and that's 1 mole. Right? Moles of silver nitrate cancel. And then our final step is going to be to go upwards to our particles. And how are we going to do that? Well, we're going to use Avogadro's number, and it's 1 mole is equal to 6.02 times 10 to the 23rd, and again, this is all of copper. It cancels. Right? We're going to multiply across the top. We're going to divide across the bottom, and our answer is, already worked this problem, the answer is 1.455 times 10 to the 24th atoms. Anytime you're dealing with atoms or molecules, it's going to be a big number. Okay? All right. So now let me come back here and let's get the PowerPoint back up. And let's work the other problem. The other kind of a problem is going to be a problem where we are looking for grams from the number of molecules. So we're going to start with number of molecules, and then we're going to go to the number of grams. So let's see how we do that one. All right, All right, so we start with particles over 1 and mass on the side. So instead of starting at the bottom, we're going to start up at the top and end up in the lower right hand side. So what do? We got to get from particles to moles. We pick the unit and we pick the conversion factor, and that's going to be using the Avogadro's number. Avogadro's number has to go on the bottom, so it cancels. Right? From moles of K to moles of U, we are going to use molar ratio again. Moles of K goes on the bottom, so it cancels. Now we're all the way over to moles of U. We go from moles of U down to grams of the unknown by using the molar mass again. All right? So it's the same thing over and over, guys. This is all we've been doing the whole time. So let's get back to the other problem. Here we got it. We are dealing with calcium chloride, silver nitrate, silver chloride, and calcium nitrate. The question reads, how many grams of AgNO3 equals 3.54 times 10 to the 23rd molecules calcium nitrate. Now, all right, so we're going to put this over 1. Molecules is really long to write out all the time, so sometimes you're going to see people write moles C. Right, so what's the first thing we have to do? We're starting here, and we have to go to moles. And you'll notice the arrow going down says we're going to put the moles on the top. 1 mole of calcium nitrate, and I'm going to mess it up, but I'm not going to worry so much about making sure it looks right. And I'm going to put 6.02 times 10 to the 23rd molecules, mole C's of calcium nitrate. And you can see that that cancels. I'm going to put this in parentheses so I don't mess it up when I do the math. I'm not going to change colors. So we're down to here. All right, so now what do I have to do? I'm going to run out of room if I'm not careful here. I'm going to put my molar ratios here. So what's my known? My known is calcium nitrate. There's a 1. So I'm going to have 1 calcium nitrate on the bottom. And I'm going to have, what am I looking for? I'm looking for silver nitrate. I'm going to have 2 moles of silver nitrate on the top. Calcium nitrate cancel. Right? So the last portion of this is going to be grams. So I'm at moles of calcium silver nitrate. How do I get 2 grams of this? I'm going to go down and I'm going to multiply it by the molar mass, which is 169 grams of silver nitrate is 1 mole of silver nitrate. And moles of silver nitrate cancel. Right, so the problem is going to be at this particular point doing this math. Please understand, if you do not put this in parentheses, you will mess this problem up. So we're going to take 3.54 times 10 to the 23rd, multiply it by 2, multiply it by 169.9. Then we are going to divide it by parentheses 6.01, or 02, sorry, times 10 to the 23rd, end parentheses. You have to put the parentheses in there because otherwise you get the wrong answer. And the answer ends up being 199.8 grams of silver nitrate. Right, so that's how you work the problems. Go ahead and watch the video again and again if you need to. Look at the PowerPoint and know that we're going to be you're also getting a Google form to fill out. All right, thank you. Bye.